name is Mr. Evangelista, and welcome to another episode of Evangelista Science. Today we're going to talk about alcohols as part of the IBChem SL Organic Chemistry Unit. And so alcohols are going to have an OH, a hydroxyl functional group. And the first reaction we're going to go over is combustion, and we've seen this before. Combustion makes carbon dioxide and water. You need to add oxygen in there, and the catalyst needed for this reaction is heat. Now, alcohols will react with carboxylic acids, that's the COOH group, to make an ester, and this reaction is called esterification. Notice that you will need concentrated sulfuric acid as the catalyst. Also note that this reaction is an equilibrium reaction, and so you will need to do things to push the equilibrium towards the product. One way you can do this is because ester has a low boiling point, it can be distilled out of the solution. So you can boil it, and the ester will be the first thing to boil out of the solution. And if you're taking the esters out of the solution, the equilibrium is going to shift to the right, making more and more esters as you remove the esters. Okay, so remember before we talked about primary, secondary, and tertiary compounds, and we're going to see here that depending on if it's either primary, secondary, or tertiary, each alcohol will go under a different reaction. The first one, we're looking at primary alcohols, and they are going to make an aldehyde. And if you reflux this reaction, you can actually make a carboxylic acid, and we'll talk about that more in a sec. So first we have an alcohol, and we're going to turn it into an aldehyde by adding so this plus kind of 0 in brackets here, this is an oxidizer. Usually it's potassium chromate. It is an oxidizer with heat, and if you add an oxidizer with heat to ethanol, you would get ethanal, which is an aldehyde. Now, if you want to turn this into a carboxylic acid, you can leave it you can leave this going and reflux, and I'll show you what reflux means in a sec, to turn that aldehyde into a carboxylic acid. And notice here that the oxidation color will turn from kind of a yellowish to a greenish. So on the picture on the left here, this is an example of a distillation setup. So if I look back at this equation, if I just want the aldehyde, what I can do is I can distill out the aldehyde because it has a lower boiling point than alcohol. That picture on the right, however, is the carboxylic acid created through reflux. So how this works is you're going to heat up your solution, and the aldehyde is going to boil out. It's going to evaporate, and then you're running cold water through this tube, and so as the gas evaporates, it's going to hit the cold water, and it's going to go back to liquid form and fall in this beaker. That's if I want the aldehyde. If I want the carboxylic acid, pretty much what I do is as the aldehyde boils out, I condense it and make it fall right back into the container. And this is called a reflux because the aldehyde is constantly going back into the solution, which gives it time to become that carboxylic acid. Okay? A couple of things when you're asked for the conditions for oxidation reactions, make sure that you specify acidified oxidation agent and heat, as well as either distillation if you're trying to get the aldehyde, or reflux if you're trying to get the carboxylic acid. Secondary alcohols, we can only get ketones. We can only get ketones with secondary alcohol. So here, this is a secondary alcohol. It has one carbon on each side. Remember, we have an acidified oxidizer plus heat, and we're actually going to reflux this so that we can get our ketone. Again, a color change, we will notice that it will turn from yellow to green with this oxidation reaction. Tertiary alcohols, you will not get any reaction even if you use the correct catalyst. You will not get a reaction. Here's a little chart that it just summarizes the things that we talked about. Primary alcohols, you can go to an aldehyde, or you can distill the aldehyde, or you can reflux to the carboxylic acid, and the color is going to change to that yellowish orange to green. Again, the preferred oxidizing agent is going to be potassium chromate right here. acidified potassium chromate. For the secondary alcohol, if we do this with reflux, we can get a ketone and same color change. Tertiary alcohols will not oxidize and will not react, and so you won't get a color change. The reason why this won't react is because it's so crowded by all of these other carbons that the oxidizer can't really get in there and react with this carbon because it's so crowded on either side.